Hello learner, welcome back to Git presentation series. I am Satyadev. In the last presentation, I talked about various version control systems, so local version control system, central version control system, and also talked about their problems. Then I discussed about distributed version control system, and I told that Git is the distributed version control system. In this presentation, let's focus on how the storage strategies work. And how many kinds of storage strategies are possible. Let's see those two things in this presentation. Now, before going to what are those things, let's see what is a storage strategy. Storage strategy is nothing but the way we want to store the changes. For example, let's say I'm only talking about one person and a distributed version control system. So I'm a developer. I'm working on some project where there are like hundreds of files. Now there is a centralized, so the distributed version control. This is I'm using Git, which is a distributed version control system. So my local machine has got all the code which is latest from the server, and server also has got whatever code I have. So I just started today. So today I have like there could be a number of files, but today I made like changes to 5 files. Right now, when I'm asking Git to store these changes compared to yesterday, so how it would store those changes? That's what storage strategy is. So there are two popular storage strategies used by any version control system. One is file based, which another is the content based. Now what is file based strategy? A file based version control system tracks changes to individual files, typically by storing snapshots or deltas of each file content over time. It focuses on the file as the primary unit of versioning. Now, content-based systems tracks changes based on the content of the data, often at a more granular level than focusing on the actual files or objects within the file. So this is about two strategies. Let's see them. Let's compare them and see what exactly they mean. Now, first of all, tracking methodology. When it comes to tracking methodology, file-based VCS as I told you earlier, version control systems, treats each file as an individual entity for versioning, tracks changes to files based on the file names, paths, and timestamps. Whereas content-based version control system tracks changes based on the contents of the files using mechanism like cryptographic hashes, etc. Identifies and stores unique versions of files based on their data. Now let's talk more about this thing. Now let's say let's take the first case. How file based version control system works. Let us say the version control system I am using is a file based version control system. Now as the example I started with in today's presentation, let's say I'm working on a project where there are n number of files. Now today I made changes to 4 files, like I added some content, modified some content, updated. Now at the end of my day, what I'm going to do is, okay, version control system, these are the files that I have changed. You just store in your repository. That's what I request. That request could be made through menu or button or right click. I mean, there are so many ways of user interface. We are not going into how to do that, but just it's a way of requesting the version control system to store the changes done by me into its repository. Now, when the request is made to the version control system for storing changes, as we discussed that it is going to be a file-based version control system, it goes through all the files. Let us there is the files names, the names of the files that I made changes are file 1, file 2, file 3, and file 4. Now it takes file 1, and as I'm only talking about local changes, I'm not talking about distributed thing, right? So local file system. So okay, it just puts these changes on top of the file that is already saved yesterday. Similarly, file 2. Similarly, file 3, file 4. It just like there is a old copy. On top of that, it puts the new copy. So again, it may not put the entire um, copy the entire thing. It only just make changes to the changes the existing thing, but it does copy stuff file by file. That means it handles changes file by file. It takes first file and then appends or updates the file with the latest data. But it do maintain the changes, whatever changes that are there. Like yesterday, for example, yesterday I typed ABC. Today I typed DEF in that file. Now it knows that ABC was typed yesterday and puts DF in that file, but it keeps that change. Okay, today DF is added, something like that, right? Some one way of representing yesterday. So yesterday version 1 is ABC, today is version 2, which is ABC DEF. Like that it will store. This it does the same process for the all the files. So the file by file it handles. Now that's what the file based system is. Now what is content based system, VCS? It's slightly different. You know, as I told you as in the example, I change it like into 4 files: file 1, file 2, file 3, file 4, right? Now it takes all those four changes as one change, one change set. So it then makes changes to individual files in this repository, just like the file based system, but it tracks the entire thing as one unit. So you can see the advantage here. Now if you say file based, if you follow file based version control system, now let's say tomorrow I want to go back to yesterday's version or a few days back version, for one particular uh, uh, you know version. Then the challenge is, like, I don't know which one is changed, right? So I have to do it file by file. I don't know that. Whereas in case of content based version, it keeps the entire content of changes as one unit. So when you say revert to so and so date, it will revert all the changes in all the files as a single unit of work. Basically the difference is to say, in a file based version control system, the changes are applied file by file. So whereas in a content based system, even though the changes are done to individual files, but the entire change is treated as one change set. Whereas in file based system, the changes are, let's say there are 4 files changed, there are 4 changes. Like that it will treat. I think this is clear now. Let's go to the next one. Key characteristics. Versions are identified by the file's location or name. Doesn't analyze, hash the content within the file. Whereas content-based systems, versions are linked to content rather than the file name or location. Efficiently handles duplicate content, ensures data integrity. I think this is because content-based systems are taking these changes as one unit. There is better way of hashing those changes or minimizing the data storage. Whereas file-based systems, it's never be possible. Again, file-based system identifies the changes file location or by file name, not by the content. Whereas content-based system, it just collect all the changes as one unit and handle and make it like a small changes, set of changes, hash it and stores it. So that's why it can store better data. Now examples of file based system are RCS, CVS, VSS, ClearCase, etc., etc. Whereas content based system example is Git, which uses cryptographic hashes for content tracking. There is Mercurial, but we are only focusing on Git today. Now another change, another thing, feature that we want to discuss is advantages. File-based system basically simple and straightforward for small projects. However, when collaboration is needed, then it's going to be a difficult thing. Again, file-based systems are easy to use, works well for tracking changes to individual files and centralized setups. Content-based systems, they can imply more efficient storage, avoid duplication by using referential identity, ensures data integrity and security by hashing content. Ideal for distributed work workflows where tracking content across systems is necessary. So, hashing is really important. The reason is, let's say I made some change. I made some change, right? And there is another change done by similar change done by the exactly same change by somebody else. You are trying to hash this. Sorry, you are trying to store the changes in the version control system. If the hashes matches, there is a collision, right? So you are trying to override on something that's already there. So then it doesn't store, and it will inform the user that these are the changes that happened, merge it. But as far as the story is concerned, it will store in one copy. I think it's clear. So I'll repeat this. There are two people trying to save exactly the same change. In that case, the system would tell them, the centralized based system will tell them that there is going to be merge required for the second person, whoever has done the change. So he will do the merging. But as far as the storage is concerned, it will store only one copy. Whereas when it comes to file-based systems, it will, it just duplicates data. There is no harm. He can get the things done. There is no difference as far as the content is concerned. But as far as the data storage is required, it needs more storage because it just stores the duplicate, right? That's the advantage of content-based system. Now, challenges or limitations. File-based systems cannot efficiently track duplicate or identical content across files. Exactly. Lacks advanced content integrity checks. I think whatever advantages content-based they are being mentioned for the file-based system as disadvantages. Content-based system. Well, because they are using hashing techniques and trying to eliminate duplicates and all that stuff, it are more slightly complicated for beginner compared to file-based systems. Well, as far as a user is, as an user, I think it shouldn't be a big problem. Because at the merge time it will have a small challenge, but other than that, it's actually it's good. I think because we are using more process, it requires some computational resources. But when you are considering this as a server, I wouldn't even consider that as a limitation for content-based version control systems. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.